Hi guys, welcome to a new video on differentiation, paper 2 questions under math studies. This video deals with questions of a difficulty of level 4 upper intermediate, and the questions in this video both feature normal lines, so how to handle normal lines. I shall solve these two questions and I shall begin with the first question shortly. I shall now attempt to solve May 2015 time zone 1 question 5. Kindly take a minute and attempt to solve, and the answer shall follow through shortly. So in question A, you are required to write down f dash of x, given that this is your function f of x. So I've taken the x squared from the denominator and turned it into x to the power of -2 in the numerator, and this shall help me differentiate, and there is my derivative function. You are next given that the graph of y equals f of x has a local minimum point at x equals 4. You need to show that k equals 3, so we know that the local minimum is a point where f dash is 0, and you are told here that x equals 4 at the local minimum where f dash is 0. So I just use these two pieces of information together. So I've plugged the 4 into the x power -3 right there, and I've equated to 0, hence finding the k, which is 3. Next, you are required to find f of 2 and f dash of 2, and these are obtainable using the graphic display calculator. So there is my function as per the question. I've only inserted 3 instead of this k, since we know that k equals 3, and I'm also going to use the window given in the question. So there is your window and there is your graph. You want to get f of 2, this is what is required in question C. So this is obtainable through second trace find value, and you enter 2. So f of 2 is 30 as per the GDC. Next, to find f dash of 2, you repeat the process, second trace, but instead of value you select dy by dx and you enter 2 again. So the slope is -21. So there are your two answers obtained through the GDC. Next, you need to find the equation of the normal to the graph y equals f of x at the point where x equals 2, giving the final answer in this form where a, b, and d belong to z, which means that a, b, and d are integers. So in order to find the equation of the normal, we need two things, a point and a slope. The point has x coordinate 2 and y coordinate f of 2, which we already obtained in C. So we have the point. The slope of the normal is the inverse of the slope of the tangent at x equals 2. And the slope of the tangent at x equals 2 is obtained by f dash of 2. So I take this slope right there, I switch the sign and I flip it, and this gives me the slope of the normal. So since the slope of the tangent is -21, hence the slope of the normal is 1/21, and the point, as we said, is 2 and f of 2, which is 30 from C. Hence I have a point and a slope. I just plug into the point slope formula. Since I want the final answer to be only integers, I want to get rid of this fraction. So I multiply by 21 on both sides, and this is the expression I get. Further simplification gives me this expression and then this final expression which matches the one given in the question. Next, I'm required to sketch the graph of y equals f of x for the given window. There is the GDC drawing and there is the marking scheme version, and we can see that you only need to just copy down what you see on your GDC to achieve the correct drawing. You get 1 mark for the correct window and at least one value other than 0 labeled on each axis, so you need some indication of your scale. Now you get another mark for a smooth curve with the correct shape. The graph should not touch the y-axis. There is an asymptote at the y-axis, and it should not curve away from the y-axis. So it has to approach the y-axis but not touch it. You get another mark for the axis intercept in approximately the correct position, nearer -5 than 0, and a mark for the local minimum in approximately the correct position as well. It has to be in the first quadrant, nearer the y-axis than x equals 10. This is of course all obtained if you are accurate in copying down what you see on your calculator. So you can see that all these features in this box are similar to the calculator. Next, I need to write down the coordinates of the point where the graph y equals f of x intersects the x-axis. So the intersection with the x-axis or the x-intercept is called the zero of the function on the calculator. So on the calculator you will find a function called zeros. Let's check this out. So second trace and you pick 0. You drag the cursor to your left bound, which is below the y-axis, then a right bound, which is above the y-axis, and a guess somewhere here, and you are told that the 0 exists at x equals -3.17. So this is your point where the graph cuts the x-axis, -3.17, 0. Next, I want to state the values for which f of x is decreasing. So f of x is decreasing in this part of the curve right there. This begins at x equals 0 but not including x equals 0, and it ends at the minimum point. So from x equals 0 to the minimum point. So we know the coordinates of the minimum point, hence we can just say from 0 to 4, because 4 is the x coordinate of the local minimum point. So this is the interval where the function is decreasing. So take a minute to copy the answer down if you will. I hope you have found this useful. I shall now attempt to solve November 2015 question 5. Kindly take a minute to look through the question and attempt to solve. The answer shall follow through shortly. So in A, you are asked to state whether the function is increasing or decreasing at x equals -3, giving a reason for your answer. So at x equals -3, the function is obviously increasing because the slope is positive. Second, you are required to write down the value of r. So in B, you want to find the value of r, given that f of x is an equation where all the coefficients are unknown, and this is the r right there. So what is the value of r? The value of r is the value of the function when x equals 0. So if I put x equals 0, what will happen to f of x? This will be a 0, this will be a 0, and this will be a 0. Hence, the value of f of x will equal the value of r. Or in other words, the value of y shall equal the value of r. So r is the value of y when x equals 0, which is basically the y-intercept of the function. When x equals 0, the value of y is 150. So these are the two answers to A and B. Next, they gave you the values of P and Q. So now you have P and Q and R. And you are required to find f dash of x. So I've written the function down with the P and the Q and the R, which we got from B. I want to find f dash of x. Excuse me, this was nx cubed at the beginning. We shall later prove that it is 10. So for now, let's just keep it as nx cubed. Hence, f dash of x equals 3nx squared, and the derivative of the second term is negative 60x, and then negative 240 for the third term, negative 240. Next, I want to find the local minimum in question D. Write down the coordinates of the local minimum point, which is this point right there. So I get the coordinates from the graph. The x coordinate is 4 and the y coordinate is negative 650. So just take a look again at the point and try to find from the x and y axes what the coordinates of the minimum point are. Now in E, I'm required to show that the value of n is 10. So since we have f dash of x and we know the coordinates of the local minimum, I can use the information or the fact that f dash is 0 at the local minimum to set up an equation. So when x equals 4, f dash equals 0. Hence, f dash of 4 equals 0, or 3n times 4 squared minus 60 times 4. I've just plugged 4 into the two x's, minus 240, which is equal to 48n minus 480 is 0. And it is 0 because f dash is 0 at the minimum point. Hence 48n equals 480 and n equals 10. So let's rewrite f of x now that we have the n equals 10. In question F, I'm required to calculate f dash of negative 1. So I've written down the equation on my calculator and I've adjusted the window as follows for your reference. Next, I click on trace and there is my graph. I want to find f dash of negative 1, so second trace dy by dx, negative 1. And the calculator tells me that the slope at x equals negative 1 is negative 150. So this is y dash of negative 1, or f dash of negative 1. In double I, I'm required to find the equation of the tangent to the graph at the point negative 1 and 350. So I need a point and a slope. I have the slope from I and the point is given in double I, so I have everything I need. I need to write the equation in this form right there. So I just substitute these values into the point slope formula and I expand and simplify, hence arriving at this final equation. Next, I need to write down the gradient of the normal to the graph at x equals -1, and this is obtained from the gradient of the tangent, which is f dash of -1. I just switch the sign and flip the number. So since the gradient of the tangent is -150, hence the gradient of the normal shall be +1 over 150. I am told that the graph of the function intersects the x-axis at point P as shown in the diagram, this point right there. I need to use the GDC to find the x-coordinate of P, and we should know that the point where I cross the x-axis is called the zero of the function. So there is my graph. I press on second trace, find the zero. There is my zero. I'm dragging the cursor towards it. There is my zero approximately. So my left bound is somewhere here, my right bound is somewhere there, and my guess is there. So the zero exists at x equals 6.388, or just x equals 6.39. There is my answer. Finally, I'm told let g of x equals 100x plus 400 for this domain. Use your GDC to find the values of x, where f of x equals g of x. So f of x equals g of x as an equation means the intersection points between f of x and g of x. So I need to first sketch g of x within this given window. So let's adjust the window and let's add the equation of g of x, which is 100x plus 400. And there is my curve. And the line. I need to find the two intersection points, there and there. So second trace, intersect. There is my first curve close to the intersection. There is my second curve, and there is my guess. So the first intersection is at -3.97. Second trace, intersect. First curve, second curve, and guess. So the next is -0.808 or 809, and we are done. Hope you found this useful.